Hi everyone. Today Peter Ivanov is going to demonstrate how to manage, store, interlink, and query your data in our cloud-based semantic database solution. Peter has a Master of Science in Machine Learning from University College London and a Master of Science in Neural Systems and Computation from the Institute of Neuroinformatics at the ETH Zurich and University of Zurich. Peter's areas of expertise include information retrieval, big data, text analytics, high-dimensional feature analysis, graphical models, as well as learning algorithms from biophysical and artificial neural networks. At Ontotext, he is part of the Innovation Consulting Unit. Today's webinar is being recorded and will be sent to all who have registered and available for viewing from the Knowledge Hub section on our website. You're all welcome to ask questions in the questions and answers panel, and during the event, Stefan Dragnev, who is the leading of Ontotext Cloud Services team, will answer your questions. If due to time limitations, your questions are not answered today, we'll certainly contact you with a response by email. This webinar will last about 1 hour. Thank you for participating today. Peter, the webinar is all yours.
Hi everyone, and thanks for the nice introduction. Before we start the webinar, let me quickly give you a short announcement. We are launching a new training course, and the first session will be on the 13th of December this year. As you see, the time will be tailored for the European, the people among you who are residing in Europe. So that will be 10 o'clock Central European time or 9 o'clock if you're in Britain. The course will be focused on how you can design proof of concept with semantic technologies using our graph database solution, GraphDB. And it will contain 3 hours worth of tailored video materials describing the main concepts of semantic technologies, as well as 2 hours worth of SPARQL exercises. SPARQL is the query language of the semantic web. And of course, we will also include sample solutions. The video materials and the exercises will be distributed to you a week in advance so that you have time to prepare at your own pace. And in addition, during the training itself, we'll have 4 hours live interactive session in which I'll demonstrate to you first how to design a sample proof of concept, and followed by that we'll have a group session in which together we design a second proof of concept. In addition to this, we've also decided to include a 1 hour free consulting session for any of you that might want to discuss a potential proof of concept that you've developed as a consequence of the course, or if you have any things that remained unclear during the training, we'll be able to address those as well. The topics that we'll cover will describe how you can model data using the resource description framework. We'll also talk about how this framework allows you to apply flexible schemas on data that is schemaless, and also we'll see how you can use ontologies in order to get automated reasoning on your data. We'll talk about how to configure and use your database efficiently, and during the proof of concept, we'll start from the very first step, where you take your heterogeneous data and you clean it up, you transform it into a single format so you can more efficiently use it. And following this, we'll also show you how you can load your distributed data in one unified data layer, and how you can query and update it again using SPARQL. We'll also discuss how you can gain much more knowledge that is freely available by using linked open data resources. And we'll talk about, of course, how you can explore your data set and also visualize your results in our GraphDB. And of course, in order to give you some extra insights into what your own proof of concept might contain, we'll talk about some domain-specific use cases of successful adoptions of semantic technologies. So without further ado, let me start with the training. As you can see, quite a lot of the topics that we'll talk about today are kind of a sneak peek into what you might see in the training. Of course, in the training it will be much more detailed. And those topics are also addressing some of the problems that a lot of previous webinar attendees shared with us that they're having when they're trying to use semantic technologies for the first time. In particular, we'll talk about how exactly you can model your data with RDF, and also once you've modeled the data, how can you actually query it. And in addition, of course, we'll talk about the difference between graph databases and triple stores. The difference is not very huge. And also we'll describe how you can choose an appropriate database solution based on which stage of your product design you are currently at. We'll mention a few of the reference projects, and following that we'll go into our cloud solution called S4. That's the self-service semantic suite. And we'll introduce you to its capabilities, and we'll talk briefly about how you can leverage the S4 REST services as well as the knowledge graph. So starting with modeling your data using the resource description framework, we'll take the following example. If you go on Wikipedia and search for the movie Thor, you see the first paragraph looks something like this. Also, you might notice that a lot of the information that's included in this paragraph is also converted into this knowledge graph on Wikipedia. For example, here you have the list of people starring in the movie, and here you have it described as well. And you also what this means is that pretty much any free-flowing information, such as this text here, can be described through relationship between things. For example, here you can have the relationship between the movie Thor and the director Kenneth Branagh, and the relationship is that Kenneth Branagh has directed the movie. Similarly, there's the relationship between the movie and the release date. And if you want to get a more formalized way of describing such descriptions, a useful tool is to use the resource description framework, as it's a standard set by the World Wide Web Consortium, or W3C for short. So what is RDF? It's a graph data model that formally describes the semantics or the meaning of the information. It represents metadata. Metadata is the data about your data. And the data model consists of triples. Those triples represent links in the graph. And the triples are formed of a subject, a predicate, and the object, where the predicate is the link or the edge, and the subject and the object are two different nodes in your graph. Example triples from the movie example we just saw is you can describe, for example, the relationship between the movie and the director by also mentioning the link, or in the RDF context called predicate, here directed by. Also, the abbreviation MDB here refers to the namespace http example.org moviedb. so that MDB Tor expands to this whole URI. The URI is the Universal Resource Identifier. It's important to know that every resource that is described using RDF is assigned a unique resource identifier so that people can effectively know which things or resources you are referring to. So if we try to figure out how the previous example looks as a graph, you can see here there's the different nodes and the edges between them. Also in RDF, we distinguish between resources and literals. Literals are data types that don't have URI, but those would be, for example, a form of text or a date, as in this example here, or an integer that you might want to store. You can also freely add more information about to your model. For example, we can decide to include some of the movie stars, and also we might want to add some information about another movie that also happens to star one of the same actors as well. However, RDF is more than just a model for representing information that you already have or that you already know. And to understand why, we have to describe first what RDF schema is. And RDF schema is an addition to RDF that adds concepts such as what resources are, literals, as we mentioned before. You can also define classes and data types of literals, and it also allows you to define relationship between the different classes or the properties, as well as defining the domain and range on a particular property, where the domain refers to defining what the class of the subject is, and the range refers to defining what the class of the object is. In addition, RDF includes entailment rules, which are axioms that allow you to infer new triples from the existing ones. So by using those entailment rules, you can gain more information. If we want to see an example of this, we have in our database the information, again, that the movie Tor is directed by the director Kenneth Branagh, and if we add the following rules, that the property directed by has a domain of class movie and the range is of class director, based on this information, we can immediately infer that Thor must be of a class movie and that Kenneth Branagh must be of the class director. In addition, we can use the hierarchy of classes to say that a director is a subclass of human, and based on this knowledge, again, we infer that Kenneth Branagh must also be a member of the class human. In addition to RDF schema, you can gain much wider capabilities of such inference and of defining restrictions and a form of schema to your data by employing ontologies. And an ontology is a formal specification that provides shareable and reusable knowledge representation. Other such formal specifications include taxonomies, vocabularies, thesauri, logical models, and also topic maps. Ontologies in particular include description of the concepts and properties in a particular domain, as well as the relationship between concepts. However, it also imposes constraints on how the relationships can be used, and it is also used to describe individuals as members of a particular concept. Some of the benefits of using ontologies is that ontologies give you a common understanding of the information that you're dealing with, and it also allows you to define explicit domain assumptions. So a particular class or property, its name might be ambiguous depending on which domain you're in. So using ontologies, you can specify what exactly you mean by using that particular class or domain. So why are those valuable? It helps you if you want to apply, as I just said, domain knowledge to your data. It also enables you to derive model-driven applications, and it severely reduces the time and cost of application development. So rather than having to go and describe that each individual director must also be of class human, by simply defining a particular rule, all of this new information is immediately inferred. And this, of course, improves your the quality of your data, as you have a way in which you can structure it and also check whether it's consistent. Now, the web ontology language is the ontology of the semantic web. It's abbreviated with the abbreviation OWL, and it adds more powerful ontology modeling means than what you already have by using RDF schema. In particular, it allows you to check whether there are any logical inconsistencies in your data, or you can also see whether you've defined some classes that, due to your definition, cannot have any instances, so you can go back and modify your definition. It also allows you to figure out what the type of a particular instance is, as we gave you the examples with using the domain and range of a particular property helps you figure out what the classes of the subject and the objects are. In addition, it adds identity equivalence and identity difference. That refers to instances of classes, for example, by using same as and different from, but you also have equivalence and difference between classes and properties as well. So it also offers you more expressive ways in which you can define your classes. For example, you might want to define a class through the disjointness of two classes, or through their intersection, or the complement of one of the classes. And it also allows you to define some cardinality restrictions. For example, you might want to say that a human qualifies to be of the member of the class parent if there's the restriction that on the property having a child, he has at least one child. In addition, it allows you to define more expressive property definitions by saying that a particular property is transitive, or it's symmetric, or a particular property is the inverse of another one. So if you want to effectively use semantic technologies, you have to be comfortable with using SPARQL, the query language of the semantic web. So it's a SQL-like query language for graph data, and you have the following query types. You can use a select query in order to get tabular results. You can also use construct if you want to create new RDF graphs based on the query results that you get. You can also use a simple ask query, which returns a Boolean value, either yes or no, describing whether there's a result that exists in the database that corresponds to your query. And you can also use describe if you are unfamiliar with a particular data or a particular resource, and you want to get some more description of it. In addition, there are ways in which you can manipulate the data that is already there. For example, you can insert new triples into the graph, or you can delete triples that are already there. But by combining the two, there's also the replacement for the update function. So you first you would delete something and then insert it. And there's also ways in which you can move whole graphs and copy them, delete them, and so on. But we won't cover this in this webinar. So an example of how you can use SPARQL to insert triples. The first thing you need to do when writing a SPARQL query is you first need to define your prefixes to the URIs, and to do that you use the prefix keyword. So here we said that the prefix MDB refers to this URI here. Following that, you need to say what query type you'll be using, and we said that we use insert data to add some more information that we have, and you then write down the triples that you want to insert. If you see here, the first one contains the subject, the predicate, and the object, and it's followed by a semicolon. The semicolon says that in the following triple, the subject is the same as the one we just defined. That is why here we don't have to have the subject rewritten again. And in addition, if both the subject and the predicate are the same, then you can just use a comma to denote that, and you only need to write the new object. Otherwise, any other triple must end with a full stop so that you can start defining the following triple. So if you see your data represented on the left, after running this query for inserting the data, your data will look something like what you see here on the right. An example of select query type is again following the same structure. So you always first have to define the prefixes, followed by the query type, and then describing your query. So here we are running the most basic query, which is saying that we want to get all subjects, predicates, and objects. And here you see the question mark here. This denotes that this is a variable rather than a resource. Here you see those are the variables that we want to retrieve, and in here we say in one context in what context we want to use them, and if you run this on your data that we just inserted, you'll get a result set that looks something like what you see here on the right. In addition, you might want to run some more complicated queries. For example, here we want to see if there are any prolific actors in our database, where we say that a prolific actor is anyone who can start in more than one movie. Here you see we define that we are first asking whether such actors exist at all. So we are looking for a movie that is starring a particular actor, and that same actor must also be starring in the second movie. And then to make sure that those two movies are not the same, we apply a filter that says that the following query must not be matched in our data. So we say that the movie 1 must not be the same as the movie 2. And if we run that, you see that we get the output yes. And if we want to rather figure out which those actors are, rather than using the ask query, we use the select query, and we simply specify what the variables we want to retrieve are. Otherwise, the body of the query remains pretty much the same. So here we said that we want to retrieve the actor as well as the two movies in which he or she is starring, and here we see that the actor in our database is Anthony Hopkins, and he's starring both in the movie Noah and the movie Thor. Now, all of this, in order to actually run it, you have to figure out a little bit about what graph databases are and what triple stores are, so that you can more effectively leverage them. So graph databases are are ways to store data in terms of entities and the relationship between entities. So they are particularly suited for data that is interconnected, as they take care of integrating your heterogeneous data sources, as well as handling data sets that are either hierarchical or interconnected. It also allows for schema evolution. As you saw before, at any point of time in time, you can define new rules of how your classes or properties are used. And in addition, it allows for relationship-centric analytics or discovery. And graph databases also allow you to navigate efficiently and perform subgraph pattern matching. Now, triple stores, also known as RDF databases or semantic graph databases, are a variant of graph databases in which the data is stored in the triple format that we've talked about so far, namely subject, predicate, and object. And additional advantages of triple stores include that the model is rather simple, and it allows you to explore your queries against schema that you might be unfamiliar with. And the schema, as I mentioned, can evolve, or it can also be completely absent as well. And another great advantage of RDF databases is that they're compliant to standards such as RDF, OWL, SPARQL. So there's no vendor lock-in. If you're not satisfied with a particular graph database solution, you can just take your data and go on to the better provider. It's also very easy to publish or consume other open data, as RDF is the standard for the linked open data community. And let me mention our graph database solution, which is GraphDB. It's a high-performance semantic graph database that can easily handle tens of billions of triples. It's also fully compliant with the W3 standards, so those are, among others, RDS, SPARQL, OWL. And it also allows for various inference profiles, including allowing you to define your own custom rule sets. And it has loads of extensions. For example, there's the GeoSparkle, which is the geospatial extension. There's also a great way in which you can rank your results using RDF rank. It's sort of an equivalent of PageRank for RDF data. You can also perform full text search through multiple connectors that we provide. And we also have extensions for blueprints and other third-party plugins. In addition, of course, we've taken care of database administrators and provided them with quite a lot of tooling options. Now, there are 5 editions of GraphDB. Those are GraphDB Free, Standard, Cloud, GraphDB as a Service, or S4, which we'll see in a few minutes. And then finally, GraphDB Enterprise. Briefly, the difference between GraphDB Free and Standard is that Free is restricted to only running 2 simultaneous queries at any given time. And the difference between GraphDB Cloud and S4 is that S4 is fully managed by us, while for the GraphDB Cloud option, you're responsible for all of the administration and ensuring that your database is up and running. Now, the S4 is a low-code database as a service solution by us, and it's for our GraphDB. and it's ideal for small to moderate data and query volumes. We have 4 different database volumes that you can define. Those are up to 10 million triples, which we provide for free, and there's also 50 million, 250 million, and 1 billion. And a great advantage of it is that you can instantly deploy the new databases when needed. So it's very easy to scale up and down as your data volumes change. And as I mentioned, as we take care of all of the administration, you don't have to worry about that. Everything is automated and maintained and upgraded by us. This, of course, allows you to experiment and prototype faster, as you don't have to handle all the extra intricacies that come with using such databases. And this, in addition, reduces your total cost of operation. Now, how would you go about choosing a particular database solution? Well, that, of course, depends on which stage of your product development you're currently at. So whether you're in the learning stage, whether you're already prototyping or designing a pilot, or you're already in the production stage. In any case, the priorities would, of course, be that you would prefer a lower cost, you also ease of deployment, greater performance and availability. So starting with the learning stage, the priorities, of course, would be that what you're using is free so that you can learn more effectively, and it's great if everything else is taken care of, so you only have to focus on learning the semantic technologies. So that is why we offer both GraphDB free and S4 as a sandbox environment in which you can play around while you're learning. If you're already in the prototype stage, you're already considering probably some more powerful solutions, which might not necessarily be free. So if your data has already grown sufficiently, you might also decide to use our second volume of the S4 service, which is up to 50 million triples. And if you're already in the pilot stage, your data is probably by now quite large, and you are running multiple queries simultaneously. That is why GraphDB free would not be suitable for this particular stage, but of course it's very easy to transition to GraphDB standard, as it's pretty much the same software. And you can also, if you're using the cloud solution, you can simply scale up to a larger database, either 250 or 1 billion triples. And of course, if you're in production stage, depending on the size of your data and your product that you're offering, you might opt for either the GraphDB Enterprise or GraphDB Standard version. Now, let me mention a few of our reference projects that might give you some insights into what is possible when using semantic technologies. And we'll start by talking about the BBC use case. I always start with this use case, as it's really the first mass adoption of semantic technologies, and it was done for the 2010 World Cup in Football World Cup in South Africa. BBC decided to use our dynamic semantic publishing platform, and soon after trying it on the World Cup, they decided to expand it to the whole BBC sports, music, and other sections. What happened during the World Cup is that there were more than 10 million hits per day on our databases, and we managed to effectively handle all of them. And what is notable about the dynamic semantic publishing platform is that it gives you a way in which you can effectively assemble web pages on the fly. So rather than having journalists manually write each individual page about each team and each player, coaches, and so on, all of this is generated automatically based on information that is already available in the forms of triples for the particular team or player. And an example of this, for example, would be looking at the sports section. If you would open, for example, the web page for the Chelsea Football Club, not only would you see results about the team itself, but also our platform is able to understand that a particular player who plays for the team might also be relevant and be displayed in the particular on the web page for the particular team. In addition, it is able to pull out upcoming games or information about the previous games, all the relevant leagues in which the team is competing, as well as additional information about the team and anything else related to the team, whether coach, other competitors, and so on. Another example is the Financial Times, who approached us and wanted to design a horizontal platform for both data and content. This platform is currently in production. However, you can already see some of its functionality on the Financial Times website. In particular, when reading a given article, the related articles are recommended through our platform, and they're based on the recommendations are based, among other things, on users' recent searches, taking into account that more recent searches are probably more informative and should be given higher weight than searches that happen a number of days or weeks ago. Another use case is for LMI, who had massive amounts of legal documents talking, among other things, about importing restricted goods, for example, from one country to another, and they needed a way in which they can effectively extract the information hidden in all of those legal documents, so that the analysts can make quick decisions in a matter of seconds to minutes, rather than spending hours digging up individual files and hoping that they find something that is relevant. In the life sciences domain, an example that I'd like to talk about is AstraZeneca. It's a global biopharma company, and they wanted a way in which they can more effectively test drugs for new potential applications. As some of you may know, when testing new drugs in clinical trials, all pharma companies have to make their information freely available. It's imposed by government regulations. And for this reason, there are massive amounts of knowledge of such clinical trials. However, it's hidden in individual documents, and to leverage them, we had to create a way in which you can integrate them together, and also use a lot of other already available linked open data sets, so that the company can find new applications as well as potential side effects or interactions with other drugs that were previously unknown. So what our solution does is it takes the clinical studies, it analyzes their structure, and it extracts the knowledge. It disambiguates the meaning, and finally indexes the documents and provides the users with efficient search capabilities. Our last example is about Euromoney, and similarly to the previous cases, they had a lot of distributed or heterogeneous data that they wanted to effectively leverage. But what was notable about this case is that not only was the knowledge hidden in text, but also some of it was contained in graphs, as you see here. So we managed to design a solution which also allows you to annotate the important terms in those graphs, so you can more efficiently find what you're looking for. Now let me go on to talk about our self-service semantic suite, and for that I'll demonstrate to you how you can use it yourself. So if you go on our website, ontotext.com, and go on products, you can click on S4, and it opens the console. You can register, or if you already have, you can simply sign in, and this takes you to the console, starting with the dashboard. Here you see I'm using currently the free tier, and it shows you whether you are anywhere near your limits, and including the information about your database. You can also manage your account settings or set some of the preferences. You should also create an API key that allows you to manage your database and also use the REST services and the knowledge graph, not only through our console, but also using third-party tools. Starting with the REST, let's start with the REST services. I'll show you. Here we have ways in which you can analyze text, whether it comes from healthcare or it's news, biomedical data, and also social media data such as Twitter. And you can also try it out for yourself. Here I've opened recent news on BBC, and if we copy the text and decide to try the news analytics, we can just paste the text, click on news analytics and execute. And you see here it immediately identifies some of the terms. For example, here we see that key phrase, and it refers to resources such as the president, or if we have a look at Donald Trump here, it identifies that that's a person, hence the different color. It also links to the instance of that particular resource, the DBpedia entry of Donald Trump, and in addition, it refers to the class definition of what a person is. And it gives you other extra information. You can also see information about organizations and so on. Another way in which you can use those REST services is if you click here on details, you see we've given some sample code in which you can use in order to figure out how you can apply those for yourself. Let's have a look at a particular example where I take again the same news and I want to rather than just copying an individual paragraph, a couple of paragraphs as I did here. I want to rather analyze the whole web page. So you can open your terminal and you can run the sample query that we have, the sample code that we've included. And it takes a while as it's processing the whole page, but in a matter of few seconds it will retrieve the results. While it's doing that, let me give you an example of what you can do as a sample application of this news analytics tool. If you go on now.ontotext.com, you can see here you can browse news categorized in different categories. There's international, business, science, and so on. Let's open this one. And here you see in the news from irishtimes.com, all the important terms are underlined. You see it distinguishes between topics and organizations, and among others, there's a person here, John McGuinness, and so on. If you click on a particular underlined information, it can give you information, as long as you see here, John McGuinness is a new concept, so it's information about him is not available. However, let's pick another news. Probably, yeah, here, if we open Stephen Gerrard, you see there's information about him, similarly to what you might see on Wikipedia, for example. However, it's pulling news from a lot of different places. It shows you information about the popularity, and as well as other terms which are often related to the particular resource. So you see it talks about teams for which he has played, as well as other players or trainers and so on. Now, another way in which you can, another thing you can do in S4 is there's the knowledge graph that gives you access to a lot of linked open data resources, and we've also included a number of predefined queries. For example, you might want to look at all the airports in a 50-mile radius from London. So if you run this query, you see that it retrieves 73 entries, which might sound like a lot. You see it starts with the big airports that probably most of you are familiar with: Heathrow, Gatwick, Luton, and so on. However, it also includes information about smaller airports, such as those only used by the British Royal Air Force, for example. And of course, you can also manage your databases here. So you can create a new database. Here I've created the smallest tier, up to 10 million triples, and you can check its status. You can also see details about the particular database, as well as check the different repositories. Here I have one repository. However, I'll show you how by using the REST services you can also create a new repository here. And to do that, let me open a number of examples. Those examples here are copied from our GitHub page. If you go on GitHub and look for Ontotext AD, there you'll be able to find a lot of examples, not only for Python, but here you see there's C#, there's Java, there's Ruby, and many more. So going back, let's first start with the example that lets you create a new repository. So what you need to do is you need to define your API key secret so that it knows that you're referring to the particular database. Then you need to define the endpoint of the database here. You have this address here as the access URL, and if you also open this address here, it brings you to the GraphDB dashboard that allows you to also explore your data or run SPARQL queries, as long as, of course, you connect to a particular repository. And for those of you who might have attended our last webinar, you would have seen our GraphDB 8 edition, and you might recognize that this is a different user interface. This is the GraphDB 7 edition, and GraphDB 8 is coming to our cloud solution in the early 2017. So you'll be able to make full usability of the extra additions to GraphDB 8, such as, for example, the Ontotext tool for managing non-RDF data, as well as a lot of extended visualization tools. Now, coming back to the Python example, here you see we've mentioned which one the database is that we want to access, and we define the new repository that we want to create. So this is country GDP. Let me just show you before here. If we refresh, you see there's only one repository. However, once I run this sample code, you see you get a request code 200. If you're familiar with the HTTP protocol codes, you would recognize that this was a successful operation. So if we refresh here, you'd see that the new database has been created, country GDP. Now going back to our dashboard, you see there are only 240 triples currently in our database. However, if we use our second example for uploading data from an external file, and we run that query, again, it was successful. So if we refresh the web page, you should probably see, yeah, you see there's now more triples, which means that the new data was successfully imported. And let me show you one more example of updating your database. Here, what we are doing is we're inserting a new data entry, and you might recognize the SPARQL syntax here. So this is a particular resource. This is the predicate, and here is the object, which in this case is just a literal, which is a plain literal containing some characters. So we run this as well, and we should now get 343 triples. We get a few more, and with that, let me get back to the last couple of slides of our presentation. To summarize what I've just shown you for S4, it gives you capabilities for smart data management and analytics. It has text analytics, as we've seen with the REST API examples. It also has a very huge knowledge graph that gives you access to a lot of linked open data resources that have been tailored not only for news, but also biomedical data, social media data, and other domains as well. And it gives you access to your database storage, so you can play around, you can design proof of concept, for example, and link it to all the resources that are available through our knowledge graphs. Great thing about S4 is that it's available on demand anytime and anywhere, as you get very simple RESTful services. Simple, however, they are very powerful, and it also we set it up so it's pay-per-use pricing rather than a fixed price, so you can only pay for what you're using, and there are no upfront commitments when you decide to try it out for the first time. Now, some extra benefits of S4, some of those I've mentioned, including that the smallest database is, of course, free, so you can experiment and see whether semantic technologies are the right solution for you. It also allows you for quick prototyping, as it's managed by us. You don't have to handle all the messy things that come with the software and the infrastructure. And it's very easy to start because of that, because you can only focus on what you need to learn, and we've also provided very detailed documentation and demo code, so you can make this learning curve even shorter. And of course, it's based on tested enterprise technology by Ontotext that has been used by a lot of major enterprises, including the ones I've shown you in our use cases, such as BBC, Euromoney, AstraZeneca, and so on. Now, for any additional information, I'd refer you to our support team at support@ontotext.com. And in addition, you can explore our resources, such as our community forum on Stack Overflow, as well as checking out the GraphDB documentation, as well as the S4 documentation. And we also have a knowledge hub, which includes a lot of white papers and posts about fundamental concepts in semantic technologies. If you want to learn more about particular technologies, you can check out the free resources provided by the W3C consortium on RDF, on SPARQL, and on OWL as well. And for other information, I'd refer you to our Head of Global Alliances Development, Georgi Georgiev, as well as our Europe and North America Sales and Business Development staff, namely Ileana Zunov and Peyu Popov. And of course, if you want to speed up the learning curve even more, rather than spending weeks learning all the technologies by yourself, I'd advise you to sign up for our training course coming up in middle of December. If you go on our webpage, you'll find the sign-up sheet where you can register and reserve your place for the training. And with that, I'd like to thank you, and I'll now address any questions that we might have been unable to answer so far.
Thank you, Peter, for this insightful talk, and thank you, Stefan, for the live answering of questions. This webinar has been recorded and will be available in a few days. And now Peter will answer some of your questions related to GraphDB, and if some of them are not answered today, we'll contact you with a response by email. Thank you.
So the first question is whether GraphDB can be used for linked open data in Arabic. I'm not familiar with the particular linked open data resource that you're referring to. However, We support a lot of different languages, so I would assume that we'll be able to handle this as well. But contact our support team, and I think they'll be able to give you much better answer than that. So the next question by Jean-François Delannoy. Can I explore the free version for my prototype needs? Depending on the size of your prototypes, I would say yes. You can either check the free tier on S4 if you have less than 10 million triples, or if it's larger, try out GraphDB free, and as long as you're not running more than 2 simultaneous queries for your prototype, you'll be able to sort it out with some help from you. I'd advise you to write up, and I'll make sure that we contact you and talk in more detail about it. What about importing data from JSON LD? We support all kinds of RDF formats, including those that are such as JSON LD are for quads rather than triples, where for those of you not familiar with quads, the last entry to the subject predicate object triple is also the context in which is a named graph. It's a way in which you can keep your individual the data coming from individual sources separate, while it's also together in the same repository. If you're wondering why you might want to do that, for example, you might decide you want to update or remove all the triples coming from a particular database, and you can easily do that if you've already included them in a particular context. So to answer your question, yes, you can import your data from JSON. Can we get a copy of the Python code? Yes, go on github.com and search for Ontotext AD, and you'll be able to find it. Okay, so we'll conclude this webinar, and if there are any questions that I might have missed, we'll address them in the follow-up email.